Good afternoon, everyone. Thank you very much for joining today's webinar entitled AI for Insurance Companies. Before we begin, a couple quick housekeeping items. If you are new to Zoom, if you click the grid view in the top right-hand corner of the viewing window, you can see both the slides and the speaker. Please use the Q&A chat function at the bottom of the Zoom viewing window to ask questions. We will answer them as they come in. And lastly, we are recording today's webinar. With that, I'll now turn things over to Kevin DeWalt, CEO and co-founder of Prolego, to take us through today's presentation. Kevin?
Awesome. Thanks so much, Russ, for the intro, and welcome everyone to AI for Insurance. I'm going to go ahead and jump right into things. So first off, feel free to take notes if you want to today, but all the fundamental concepts we're going to talk about are covered in our book, Become an AI Company in 90 Days. You can download an e-copy off our website at prolego.io, or if you contact Russ Franz, my business partner who introduced us, he'll be happy to send you a hard copy as well. Just connect with him on LinkedIn. So whenever we talk about AI or any kind of technology, rather than just kind of drone on and talk about the background, we want to give you really specific skills you can use in your workplace and take immediately and apply right away. So the first one is I want to give you an understanding of some of the basic AI principles so that when you're meeting with your data science team, when you're talking with about executives, if you're doing strategic planning, you want to kind of understand what some of these terms mean and how to use them. The second is I want to give you some basic heuristics to discover AI opportunities in your organization and figure out which ones might have the biggest impact and be the most important for you to pursue. And finally, I'm going to help introduce you to some common mistakes and patterns we see at insurance companies where, avoid some of the pitfalls, just so as you start working into getting closer to doing actual projects, you'll know what to look out for. So with that in mind, let me just start off by kind of setting the context for why we're here today and why we're having this conversation. If you've been in tech for any period of time, you know that every 6 months or so, there's a new buzzword that comes out that's going to magically change everything, and it's a revolution, and it's disruptive, and yada, yada, yada. And most of the time, most of the technology changes we see are really just evolutionary. They are different ways of doing the things that we already do. But once a generation or so, some new tech comes along that really does fundamentally change how we work and change our society. And I'm talking about things like electricity, microprocessors, computers, most recently the internet, and then currently AI. And these changes really are revolutionary, and they just change not only how we work, but society and how we interact. So in the case of AI, if you look at what computers have done for businesses over the past 50 years, they've primarily helped us do two things. First, they've helped us communicate more effectively. And second, they've helped us work more efficiently. Well, in the era of AI, computers are now going to be doing a new function for us, and they're going to begin starting to think for us. So a lot of the cognitive tasks that we do in business today, we're going to start offloading those to AI algorithms to have them do for us. And it's going to fundamentally change how we work. So the question we get asked, given all this revolution that's happening in AI and, given the technical background of our people, why does Prolego specialize in insurance? What's so interesting about insurance? It turns out insurance is a really fascinating space to work in right now. For one thing, insurance companies have always been data-driven organizations. They have since the dawn of time, right? Insurance, actuarial science, they tend to be some of the most data-driven organizations and data-driven companies. But traditionally, they have not been technology companies. And so with the arrival of machine learning and AI, you have this collision between being a data-driven enterprise and being a technology enterprise that is really causing fundamental changes in what insurance products are, how they're sold, and how insurance companies operate. And it makes for some really interesting problems. Additionally, this fundamental change is creating a very different competitive dynamic for insurance companies. And we see emerging competitors, the big retailers, Walmart and Amazon, the tech companies. There's a lot of threats for people who are non-traditional actors to start getting into this space because of the economics associated with insurance products. And so it's becoming a highly competitive, a highly industry, and insurance companies are more and more becoming tech companies. And so the exciting work for us is helping our clients begin taking the first steps to become part of this journey and to begin applying AI to solve some of their business problems. Okay, so let's jump into it. Let's talk about some of the AI fundamentals. I want to give you an understanding of some, the basics of what these terms mean. And the reason is, like, unfortunately, there's still a lot of BS and nonsense in this industry. And we will see, companies will have roadmaps and plans often put together by, outside consulting firms. They'll say things like, in Q3 2020, we want to start applying machine learning to our data lake. Unfortunately, these throwing words like this together really don't mean anything. These words have some very specific meanings and they have implications. So let's talk about what some of these words are and what they mean. The first is simplest, which is AI. AI just means intelligent computing. I use the term when I deliberately want to be general, just the way I would say the Internet of computers. It really doesn't tell you much about what task you're trying to solve or how you're going to solve it. So that's why I called the webinar today about AI for insurance, right? It's a very general term. Machine learning is a type of AI, and it's actually a different way of building software. So we're going to spend most of this discussion talking about applications of machine learning, and we're going to start by talking about what machine learning is and isn't. Deep learning is a type of machine learning, and it represents the state of the art of AI. I'm not going to spend a lot of time talking about the difference between deep learning and machine learning, but if you hear the term, just know that it really represents state of the art of AI. And finally, I'm going to start off by talking a little bit about a term called data science, because unfortunately, people will use a lot of these terms and it becomes it's kind of hard to figure out what they're talking about, especially when it gets into individuals' titles within an organization. So data science overlaps with AI, but you can do data science without AI. So let's start off by talking about what we mean when we say data science. So you may hear the term data science in a business context if you follow sports, the NBA or NFL, baseball. You may have heard of analytics or statistics, data analytics. These terms all basically mean the same thing. And they're about taking a more scientific approach to extract knowledge from data using statistics and computation, and to use that information to answer questions. So that's basically what data science is. Of course, in business, a lot of times we have data scientists as a title, and data scientists can be using data science to answer questions, or they begin doing things like analytics, data cleanup, data engineering, or even machine learning engineering. So what is data science for? Data science is primarily for answering basic business questions. Things like, where should we send our new marketing campaign? Who should we target to it? How do we segment our customers based on the kind of products you might be interested in? How do we get better ROI from our marketing efforts? Should we go to conferences or do online advertising? I mean, almost any question you can ask. And if you're talking about the National Football League, it's, do I kick the extra point to go for the 2-point conversion? These are the kind of business questions you can answer with data science. What we really want to talk about is machine learning, because the bigger impact from all of this technology is not about answering questions, but it's about building software, about building technology that can do a job for us. We're going to spend a bunch of time talking about this definition of machine learning. In machine learning, a developer uses data to train a model how to perform a specific task. Machine learning fundamentally is a different way to build software. So the easiest way to explain what machine learning is to talk through an example. Let's say that you want to build an application that detects whether or not a customer visiting your website is ready to buy an insurance product or a financial services product. So you can imagine you have a visitor to your website, maybe you know some information about that prospect, they do a bunch of activities in your website, they watch a video, they click on a page, they go to the pricing page, they sign up for a form. And you could take all that information and you could feed it into an algorithm that tries to detect whether or not this person is ready to buy a financial services product. And that information could be fed over your sales and your marketing team where they can act on it. They can send off marketing automation, they can give the person a call, they can offer them a discount, whatever that group wants to do. So this is a fairly classic application for AI in a financial services company. So let's talk about ways to build that application using traditional software. Well, you could imagine that a software engineer could sit down with your sales team and say, hey, sales team, how do you know when a customer is ready to buy? And the sales team may say things like, well, if they visit the pricing page, if they are qualified based on where they live or what they do, if their income's over a certain amount of money, they can get information back from the sales team, and the developer can use that information to write a set of rules that tells the computer what it wants to do. And so the developer literally goes in and tells the computer how they want to analyze customer events coming through their website to determine whether or not a customer is ready to buy. And again, this is how 99% of all software is built. And this way of approaching software has a couple of advantages. For one thing, developers are smart people, and they're very good at abstracting the real world. So this is actually a fairly quick and easy way of taking complexity and building an application that can solve problems. But unfortunately, it has some limitations. Namely, it doesn't scale very well. So if you talk about more complex problems with lots of data and more complex rules, they get brittle and hard to manage. And so systems get difficult to update. You get edge cases where they don't quite work, and then over time, they don't become as effective. So as a result, more and more companies are using a different way of building software called machine learning. So again, going back to our definition, in machine learning, a developer uses data to train a model how to perform a specific task. And so let's talk about what does that mean. So if we're going to try to solve the same ready-to-buy detector using machine learning, here's what we would do. First off, we would look back over the past several months' history and gather up spreadsheets of all of the customers who visited our website and segment them into two groups, those who bought and those who did not buy. We would take all of that information and organize it along with all the information or features we have about those customers, and we would start feeding that information into a machine learning algorithm. Now, that algorithm would take this training data, it would make predictions, and based on whether those predictions are right or wrong, that feedback would be fed back into the algorithm where it can learn to make better predictions. And your data scientist, your machine learning engineer, would use this process to teach the algorithm how to make correct predictions. And after he or she is done, you have a machine learning algorithm that can take a new customer in and automatically make a prediction as to whether or not this customer is ready to buy or not buy. So this machine learning approach has a number of advantages. It tends to scale well, it tends to adapt well, it's easier to maintain at high volumes, but it comes at a cost. And that cost is all the complexity around organizing and getting this training data. So machine learning is not a good option if you have small amounts of data or if you have relatively simple rules. So that's the basics of what AI and machine learning and data science are. Now let's talk about a couple of the concepts that you're going to have to understand to be able to work with your data scientists, develop AI strategies, and participate in discussions. Two concepts are data and models. So let's start with data. Data for machine learning consists of two types. The first are the inputs. That's the information that feeds into your machine learning model. It was, in our previous example, it was all the information that came from the customer's behavior on the website. And the outputs, that's what your machine learning model produces. So we've got inputs and we got outputs. So whenever you start a data science project or you start thinking about how are we going to use AI in our application, you should start by thinking about the outputs. What do you want the machine learning model to do? And in the book, you'll see we have a bunch of different examples of outputs. But I find this to be a very useful approach when I'm thinking about any kind of machine learning application. And I'll give you a quick example. A couple of months ago, I was walking around one of our client sites at an insurance company, and an executive stopped me in the hall and said, hey, Kevin, you got a second? And he started to tell me about claims and, the claims they had coming in and how they were managing them and where the data was going, what they were doing with it, and his mandate to make it more efficient. And after about 10 minutes or so, I kept asking myself, what's the output? What are we trying to accomplish here? And so I said to this gentleman, I said, okay, so you want to take a model and you want to automatically predict whether or not a claim has a higher probability of being fraudulent or not. And he said, yes, that's it. That's exactly what I want to do. So it's simply focusing on the output and kind of cut through a lot of the complexity and nuance and technobabble associated with AI. So always begin any kind of strategic AI discussions by talking about outputs. What number do you want these models to produce? What do you want these models to do? And the second part of data is the inputs. Input, again, is all the information that feeds into the model that makes a prediction of the output. So the second step when I'm looking at any sort of AI project is to think, what's the data? Do we have inputs? Do we have data that might be correlated with our particular output that we're trying to predict? And oftentimes, you can get a good sense of whether or not you have an opportunity for AI by talking to the people that use the application and doing some simple analysis on the data you have. So those are the basics about data. Let's talk a little bit about models. So models, there's lots of talk about models, and everybody in data and in conferences and developers, we all want to talk about AI models and all their power. When you think about planning your AI strategy, the specific model that you're going to use and how you're going to use the model, that's usually one of the things you worry about later. And your data science and your engineering team are going to be very good at helping you decide what are the right models to use in a particular application. But just so you understand what do we mean by model, we're going to walk through a very simple example. All you need is a little bit of 8th grade algebra to be able to understand it. So imagine for a second that we have a bunch of data. We want to make a model to make predictions on that data. And we've outlined the data on the screen here. You have the X, which are your inputs, and those you can see along the horizontal axis, the X-axis in the bottom. They go from 0 to 9. And you have Y. Those are your model outputs, and they range between 0 and 0.2. And so you want to come up with a model that's going to predict Y based on X. You want to predict your output based on your input. So with that in mind, you go open your 8th grade algebra textbook and you crack it open and you find a model that might work. And it's Y equals mx plus b, which is the equation for a straight line. And you'll see that we have Y, which is the output, X is the input, and while we're training the model, we want to discover what is M and what is B. We want to discover the M and the B that are best at predicting Y from X. And as you go through that exercise, you discover that M is 0.1 and B is 0.45. And you can see what that looks like. It's the equation for a straight line that you learned in 8th grade algebra. That's the world's simplest machine learning model. So that's a little bit of background about AI fundamentals. And I think if you kind of understand those concepts, you're going to be in a position to participate in discussions and to kind of understand how your AI projects are working. But let's go a little bit deeper now. Let's talk about how you discover AI opportunities in your organization. And specifically, we're going to talk about how you discover AI opportunities in insurance. One of the things that makes this so confusing is there's just so much technical babble and confusion in the marketplace about AI. And it's very easy to get lost in the underlying tech when people start talking about convolutional neural networks and recursion and regression. And we have all these technical terms. So the question is, can we kind of take a step back and can we look at some heuristics or some basic rules to help figure out, do we have an opportunity for AI on this particular problem? So we've developed what we call AI product patterns. And these are recurring ways to apply proven AI technology to solve common business problems. And we're going to talk about 4 of them. The first one is computer vision. Computer vision has been around for decades, and it's been a very difficult problem for researchers to solve using traditional computer science techniques before AI. So there would be, every year you would have complicated tasks that would, like this contest on here of cats versus dogs, where you have researchers trying to look at a particular set of images and determine, does the image contain a cat or does it contain a dog? This was a really challenging problem for researchers until about 2013, 2014. Then with the advent of AI, researchers were suddenly able to achieve state-of-the-art results and get exponential improvements overnight. And in today's world, this is actually a trivial problem, and anybody, even with a modicum of computer science experience, can download off-the-shelf algorithms and solve this problem. So computer vision is your first product pattern. In insurance, we typically see applications for computer vision in like auto and property and claims data, where you're trying to quickly evaluate whether or not a customer has a particular set of damage. For example, there's an image classification problem where a customer submits damage on a vehicle, and you can kind of detect in the vehicle where did damage happen. Maybe it helps you do estimates, or it helps you detect whether or not the customer was actually in the accident that they claim, or if something else happened to the vehicle. Another example is image segmentation. So if you have images maybe from property, if you're doing property and casualty, that you can look across a particular region and identify, where are the areas in question that we're interested in evaluation in terms of our coverage. One of the biggest challenges in computer vision is data labeling. It's organizing all the training data that you're going to use to feed into your computer vision algorithms. Normally what has to happen is you actually have to have people who go through a set of images and hand label them to look for the information that you're seeking. Sometimes that can be classifying entire images, or like the example on the screen, it can involve somebody selecting the image from a particular part of the screen. In this particular example, you have a bunch of football players, and you can imagine you're trying to determine which players on which team, which is the ball, which is a ref, which is a fan. You can imagine that someone's trying to segment different parts of this image to identify specific pieces of information they want to predict in an algorithm. So this tends to be one of your more expensive, challenging parts of doing computer vision. Okay, so that's computer vision, our first product pattern. The second product pattern, the one that I'm most excited to talk to you about, is natural language processing, or NLP. NLP is the process for using computers to generate, interpret, understand, natural or human-generated language, things we say, things we speak, things we type on the screen. Not information that tends to be in a database that's highly structured. There's a couple of different reasons why I'm really excited about natural language processing for insurance, and why so many insurance companies are now starting to invest in natural language processing initiatives. The first is that we have tons of natural language data all over insurance companies. So in spaces like retail, they've got lots of structured data, and in automotive, they got lots of images, but in insurance, we've got lots of paper. So our contracts, our applications, our claims, our chats, our emails, our customer conversations, all the spoken conversations between our sales reps and our customers, between our call centers and support centers and our customers, all the resumes that HR have. I mean, there are tons of applications for NLP in insurance, and that's why most insurance companies we work with are starting to invest in NLP as a fundamental capability. But there's actually even a more interesting reason. And the second reason is that NLP is getting incredibly powerful. And in particular, the cost to build state-of-the-art NLP systems has plummeted. And so if you're interested, there's a particular research paper that came out about 18 months ago, which is on the screen, called You Will Unfit. Previously, you had to have Google level of budgets to build up enough training data to build an NLP algorithm. But now there are new techniques and new algorithms that are coming online, where a small work group like our team can download them for free and start using them on client projects to make a difference. So the cost has plummeted. The third reason is that the NLP algorithms are getting incredibly smart. They're getting better and better at understanding meaning in documents. So I'm going to show you some examples. First off, this one is some text generated by OpenAI. OpenAI is a profit-capped company in Silicon Valley that started to kind of advance the state of the art of AI and help create innovative AI algorithms. They developed a NLP model which helps automatically generate stories and sentences. So you feed it a sentence and it spits out a story or a sentence associated with it. So to give you an example, if you feed it a sentence that says a train carriage carrying controlled nuclear materials was stolen in Cincinnati today, its whereabouts are unknown. This model can take that one sentence and it automatically generated on a first try all the information that came out after that. The incident occurred on the downtown train line, which runs from Covington and Ashland stations. In an email to Ohio news outlets, the U.S. Department of Energy said it is working with the Federal Railroad Administration to find the thief. Now, this is pretty amazing. So If you just imagine for a second, this is a generalized model that automatically generated this story. And if you go onto their website and look at some other examples, you can see that the same algorithm can generate stories about, Miley Cyrus stealing information, or it can create a rant that you would see on social media about a topic like recycling. So these algorithms are getting very good at detecting meaning and understand what's actually happening in language. Well, these same algorithms, we can actually download and tweak them a bit so that we can apply them to particular business use cases, like determining whether or not the chat coming in from one of our customers indicates that a client that might be at risk and want to cancel, or might be ready for an upsell for a different financial services product. So in summary, we've got tons of text data insurance companies. The cost of building system is plummeting, and at the same time, they're getting really, really powerful. So lots of things you can do with NLP, and if you kind of look at the space, you can see different examples. In particular for insurance applications, the number one application we see is categorizing text. So taking a set of text, organizing contracts, organizing chats, organizing emails, segmenting text information that you have into different buckets based on various areas that can drive business value. That's really the first place we see NLP being applied at most of our insurance companies. How to spot NLP opportunities? If you go around your organization, most of our clients just start talking to different business owners. They talk to HR, they talk to support, they talk to legal, they talk to sales, they talk to underwriting, you can talk to claims, you can talk to contracts, you can talk to customer support, your call center, and just start asking some of your business leaders, how do you currently use unstructured text? How do you use language in your day-to-day work? And if we can teach an algorithm to read and understand that text and to categorize it in a way that would drive business value, what would that do for you? Typically, when our clients do this, they will come back with 20 to 30 possible applications for NLP in their companies. So again, that's why NLP is just so interesting for insurance applications. A couple quick comments on sort of kicking off projects, specifically with NLP, is to set achievable initial goals. Sometimes we see that when you talk to your clients about your customers about what you can do, you can get really excited, like, wow, we can do some fully automated, cost-changing application with NLP that's going to radically change your cost profile. But those tend to be very high risk. So instead of going for your highest risk projects, which could make a huge business impact, try to take a step back and look for ways that you could take the same technology and apply it to a lower risk business problem that also has a big impact. So for example, instead of trying to completely automate your support, start by using NLP to automatically segment your chat messages from customers into those that are high risk. And instead of automating all of your document and claims processing, start using NLP to automatically flag those particular documents where you have risk of fraud. So finally, some challenges around natural language processing. The biggest one, again, is data. And in particularly, there's a big challenge in actually building up the set of training data to feed into these algorithms. And there's a couple of reasons for that. The primary one being that reading through lots of text data and understanding it and categorize it tends to be pretty difficult. Unlike an image where you can have a low-cost resource quickly take those images and label them, in text it becomes really difficult to process all this information. Your lawyers cannot take off 3 months from their work to sit down and hand crank through contracts and sort of organize everything into a nice set of training data for you. And there's a couple other data challenges related to this. We actually have another webinar specifically on NLP for insurance companies. And if you're interested in that and interested in more NLP, I suggest you attend that webinar because we go a lot deeper into some techniques for overcoming these data challenges. Okay, then our third pattern is next in sequence. This next in sequence is a general term we use to describe what some people may call structured data, traditional machine learning, tabular data. It's basically ways of using usually more traditional machine learning models to make predictions on the kind of structured information you would find in a database. So if you're looking at where you're using any wearables or devices, IoT devices with your customers that are covered under your policies, that might be an application of next in sequence. sales and marketing data, looking at online user behavior, or other data within your infrastructure, data that looks at security or server logs to try to look for anomalies. These all tend to be kind of grouped under this umbrella of next in sequence predictions. So we've got a couple different applications here. I just mentioned some of these. Typically where we see this in insurance companies is in sales and marketing or in IoT. Those are really the areas where we most see next in sequence, and also some underwriting as well. So when I say stuff you normally see in a database, just to give you an example of that, I mean just that. So if you're looking at sales data for a retail outlet, you could imagine that you would see, dates and stores, temperature, information you would see in a database. You would not typically see images and text documents and unstructured information inside a database. If you're looking for next in sequence opportunities, the best way is to actually look at your existing systems and processes which make predictions. Underwriting is a good example, right? So in underwriting, you're making a prediction about the level of risk and that you have with a particular application and how you're going to cover it properly. That's why most companies are looking at investing in AI for underwriting applications. You could also start looking at your data dictionaries and look at your KPIs, your key performance indicators. What are you currently measuring in your business today? Are you looking at how long a particular business process takes? Are you looking at the cycle time it takes to process claims or to process underwriting application? If that's important for you and you're measuring it, that's usually an area where you can start using machine learning algorithms to make predictions so you can act on and change your business process. And finally, there's always new data sources coming out in the marketplace and coming available. Keep an eye out for these and see if you could use any of those in next in sequence models to make predictions. I'll say a couple of words about building training data for next in sequence. This tends to be an engineering problem that needs to be tackled by your data scientists or your engineers. It doesn't usually involve hand labeling data by experts. When you start one of these problems and you give a bunch of data scientists information, they will typically tell you, say, okay, I've got to do a couple of months of data wrangling or feature engineering right now. What they're trying to do is they're trying to look for patterns inside the data that might be more predictive of the output you're trying to attain. So I'll give you an incredibly simple example of feature engineering. Let's pretend for a second you've got a convenience store and you've got just two pieces of information, the date and the amount of beer that was sold at that store. And at first glance, it's not immediately obvious why there are different amounts of beer sales on particular dates. Like, why is January 5th have the highest amount of beer sold? We can imagine a very, very simple feature engineering problem where your data science would extract the day of the week from that date, and it becomes immediately obvious why the data has this particular pattern. And you can see that there's more beer sold on Saturdays, not surprisingly, than other days of the week. Okay, so final product pattern I'm going to cover, and I'm going to touch on this one quickly because we don't see as much of it in insurance, is collaborative filters. Collaborative filters are good for trying to draw conclusions about user behavior based on what previous users have done, usually on a website. A classic example is the Netflix movie recommendation system. So if you have millions of users looking at movies and you want to try to determine what kind of movie what kind of movie should we recommend to this user, you can usually look back to the previous patterns of behavior of similar users and make a recommendation. Collaborative filters allow you to do that at scale using machine learning and statistics. So that's the primary use case. And in insurance, it's usually with product recommendations. So collaborative filters usually will become a part of a product recommendation system at an insurance company. So what kind of financial services should we recommend? What kind of financial products? Or what information should we put on the website sort of real time with this customer to try to help drive a particular transaction? Those basic four patterns those are my go-to tools. So whenever I'm looking at a new project or talking to a client, I'm usually trying to figure out what product pattern am I going to be using. But of course, this does not even begin to touch the surface of all of the great change that are coming about AIs and all of the other different ways that are being to build AI technology. And so two other pieces of technology you may hear about that we've used at insurance companies is reinforcement learning and generative models. So I'm not going to spend any detail on either one of these, except to say that we are finding situations where companies are interested in using reinforcement learning, not to beat video games, as you will often hear if you look at the research in AlphaGo, but to actually solve real business problems. And in generative models, you may see these online with deep fakes. The example here of Amy Adams, transposed to Nicolas Cage. These are all creepy, and we wonder, how it would actually use this thing in a business context. We don't actually use these to generate deep fakes, but we use the same underlying algorithms to generate new models and more data that we can use to solve business problems. Okay, so those are the 4 product patterns and its basic ways for how you can identify opportunities in your business. But if you sit down with your team for a couple of weeks and you kind of look through your environment and you start segmenting your environment into opportunities to apply these patterns, you might discover that you have tons of them. And then you'll be faced with a problem of how do we triage? How do we identify what are the business cases that we can actually pursue? Well, as a result of working with a bunch of different insurance clients, we've created what we call the AI Canvas. And this is a simple framework to help you organize your thinking and decide, is this particular AI opportunity worth pursuing for our business? I'm not going to spend a lot of time going through the details of the Canvas. We cover this extensively in the book, but basically it's divided into 2 halves. On the left-hand side, you have the business questions like opportunity, like who's going to use it, should we do it, and what are the legal implications? And on the right-hand side, you cover some of the technical issues, the nature of the solution, the data, what kind of models we're going to use, and how are we going to know if it works when we deploy the system. For a lot of our projects, we don't necessarily fill out every block of this canvas like you would in a sort of a classroom exercise, but it provides a pretty good way for us to sit down and organize our thinking. It helps point us in the direction of the kind of questions we should ask. And so a common question is, looking at on the canvas, on the left-hand side of the consumers, who's going to use the model output? Like, where's it going to go? Is it going to go to a person? Is it going to go to system? Is that person or system ready to adopt it? And these are some critical questions you need to understand at the outset of an application before beginning development. So that's the basics of the AI Canvas. Okay, I want to cover as a last part, I want to touch on a couple of more practical topics, which you're not going to hear much about unless you spend a couple of years working in this industry and have to kind of go through some of the real challenges that it takes to begin deploying AI in a modern insurance infrastructure. So some lessons learned. The first one is don't be talked into delaying any kind of AI efforts while you fix your data problems. So oftentimes we talk to a client, we'll hear things like, well, before we start doing machine learning, we're going to clean up our data. We're going to get all of our data from our organization into a big data lake, and then we're going to do machine learning. And this tends to be a bad idea from a couple different reasons. The first is you never get there. Right, and building out a data lake always ends up taking 10 times longer and 10 times more money than anybody originally anticipates, because the data is always changing and you have competing priorities of how you're going to use this information. So it ends up becoming one of these black hole projects that goes on for years until the CFO gets mad and shuts it down and fires everybody. Right, so you kind of never really get there. And the second reason, it creates a lot of waste and it's not necessary. Quite often, for the sake of machine learning, you don't need all your data. Usually you need a couple of dozen critical data sources that you can use to make predictions. So instead of trying to solve all your data problems at the outset, kick off your machine learning project and start identifying the data sources you do need, the ones that are most valuable, that are most predictive, and systematically use a scalpel and start solving them in your infrastructure and making them more robust and more reliable. And that's a much more cost-effective way to be able to start doing your machine learning projects. The second advice is to consider probabilities whenever you kick off an AI initiative. After 30 years of building software myself, I've got all the battle scars that many of you have of how challenging software is, and especially in a large, complex environment, a highly regulated environment like insurance. Building enterprise software is incredibly tough. It's also unpredictable, and it's really hard to predict at the outset how long things are going to take. In AI projects, those risks become exacerbated because not only do you have all the risks associated with a traditional software project, but you also have the uncertainty of not knowing how well are these models going to actually work in production. So there's that bit of unknown. So as you start planning projects and as you communicate with your constituents and your executives about what you're going to do, be sure to bake in at the outset of these projects the opportunity to step in and check whether or not the goals that you want to achieve that are actually being achieved. And so we've got some different techniques for doing this, what I can share with you if you're interested. The third thing is pursue multiple projects in parallel. If you think that NLP or one of these other technologies is an area that you want to invest in, my suggestion is you identify a couple of initiatives and pursue them in parallel. The reason is that quite often there are externalities that can cause your AI project to be delayed, which you won't have any control over. So even if you have your team's doing great and you're getting good results and everyone's excited about it, there can be reasons why these projects get really delayed. The most common reasons are the data you need is not available or accessible in production, or that your business partner or downstream system is not ready. You can build you have the aspirations to build the world's greatest contract search and contract segmentation project ever. But if the legal team, your business partners and contracts are not available to help you for 6 months, it's going to be very difficult for you to make progress. Similarly, if you're looking at deploying something in production, there's a particular system that you need to interface with. If the people running that system say, we can't work with you or integrate your model for 6 months because we're trying to finish up last year's release, then that's also an externality that you really can't control. So pursue multiple projects in parallel. Start planning for production early. I can't emphasize this one enough. We find among our clients that actually taking these machine learning models and putting them into production tends to be the biggest challenge they have, because there's a lot of the software and these tools are new and you have to kind of build a lot of them from scratch to make everything work correctly. So before you start getting too far into your project, start having the conversation of like how you would put it into production and who would put it into production. Unfortunately, there's a lot of hype and promises by vendors out there, some of whom have very, very good products out there, that their particular technology is going to be the solution to productionizing AI. And in practice, this just isn't the case. They can help accelerate or improve the production process or make it a little bit more seamless in some instances or easier to manage. But there's still so much that has to happen to get one of these systems into production. So start addressing those details early. The final point I want to make is, like any software project, do your best to use lean startup techniques to deploy early and iterate. You want to start confronting your non-AI challenges as early as possible. And in AI, this is particularly exacerbated because data scientists are often trained to try to build a better and better and a more predictive model in isolation. So we see oftentimes teams will have a bunch of data and they'll spend 3 months working on it and getting some decent results, but then they want to spend another 6 months to a year working on it to get even better results. And there's a couple problems with that approach. For one, the more time you spend on it, usually the much harder it is to put into production. So you're sort of increasing all of your upfront investment to productionize the model. But you're also, and most importantly, you're not really confronting your hardest business issues if you keep delaying production. So things like, are the users really going to use it? Does it solve a real problem? Do we have our interfaces right? Do we have everything lined up from legal? Do we have the production infrastructure set up and configured to be able to handle it? The best way to confront these issues is to confront them head on. And when you get the initial goals with your machine learning models, start putting them into production early so you can attack these challenges. So that's it. That's the primary. That is the primary content that I wanted to cover. At this point, I will kick it back over to Russ to sort of answer any questions we might have from the audience.
We'd like to thank everybody for their participation on today's webinar. If you could, if there are any follow-up questions or if you'd like to talk in more detail about the things that we shared with you here today, please contact me at russ@prolego.io or send questions directly to kevin@prolego.io. We look forward to hearing from you. Thank you so much.
Okay. That was pretty good. You there?